In this video, we're going to begin to look at protein degradation. Now, when we think about the half-life or the time it takes to break down 50% of something, the half-life of the enzymes inside your cell will vary greatly depending on what they do. So we can see that we have some half-lives ranging from the minutes to just a couple of hours. And then we have other half-lives that are ranging up to a week. And when we look at these different proteins, we see that the most rapidly degraded proteins, they're at the control points for metabolism. And the most stable protein or enzymes are those that work under any conditions, which makes sense. You don't want to destroy them if they're always working. Now, the part of the cell that's going to be breaking down our proteins, that's the lysosome. And the lysosome has roughly 50 hydrolytic enzymes. These are proteases for the most part, and protease is simply a name for an enzyme that breaks down proteins. And these proteases inside the lysosome are known as caspase. Now, the lysosome itself has an internal pH of 5, which is good because the enzymes inside the lysosome are only active at this low pH. So if the lysosome accidentally leaks into the cell, most of the proteins of the lysosome won't just eat the proteins inside the cell. Now, the way that the lysosome works is through autophagy. So the things you want to recycle, the proteins, the enzymes, they're going to be enclosed within a vesicle that can then fuse with the lysosome and it can be destroyed. Now, for normal, well-nourished cells, protein degradation is non-selective. That is, you're going to be breaking down everything when it gets older. However, if you're starving, you're going to be more selective because some proteins you want to continue working until the very last moment. So you don't want to destroy those if possible. And the way that we can have these selective proteins is that some cytosolic proteins will contain the pentapeptide KFERQ. This is kind of a signal that these proteins are okay to be degraded. With that, we'll continue on with our degradation in the next video.